Hello, everybody. Welcome to the September 2020 San Jose Astronomical Association Imaging Special Interest Group meeting. I'm your host, Bruce Bronstein, and tonight we are very happy to be having a presenter who's a member of our club, Hy Murveit, and he will be telling us about KStars astro imaging software and his recent contributions to KStars. He's a developer for KStars. So with that, I'll hand it over to you, Hy.
All right. Hey, Bruce, by the way, on my screen right now, or anybody, what's on my screen?
We see you're sitting at your table looking at your telescope.
Okay. I see. So you don't see me. Okay.
No.
Okay. Well, I can leave that on. Whatever. That's the presentation, right?
Yes.
All right. Well, let's get started. I wanted to, well, only a few of us, but I wanted to break the ice with some a little quiz. I had mentioned that I had mentioned to some of these other folks before. Oh, actually, we're starting to get a few people come in right now. That I was taking some classes, some astronomy classes these days. And so I've taken this astrophysics class, and this has nothing to do with my presentation, incidentally. And the professor asked an interesting question, so I thought, unmute your mics and answer the question. The question the professor asked was, why do stars shine? So, any answers? Anybody wanted to? Why
do they sparkle, or why do they shine?
Why do they shine?
Okay, that's what I was thinking too, sparkle. But
No. This is the obvious question. No, it's not a trick question. I mean, the answer may be a trick, but the question isn't why. Why do they give off all the light they do and warm us and all that?
Isn't it the hydrogen?
Hydrogen fusion is the common answer, but is not the answer he was looking for.
Well, I know something about atmosphere. Well, why we see the stars twinkle has to do with like the way that our atmosphere, like the light bounces or something like that. Like,
right, that's correct. The light, the seeing messes up. Yeah, it moves the stuff around. But why are they bright? Why do they give off heat?
I can with that.
Go ahead.
Nuclear fusion happens in the core of a star. The energy
fusion leads to the brightness, but isn't a direct answer. If the fusion stopped, we would still the star would.
Yes, I'm not through. I'm not through. The energy gets transferred to the outer edge of the star by a process of conduction and convection. I'm a civil engineer, so thermodynamics is big in my life. Okay.
You forgot radiation, but this is a two-word answer. We don't want a PhD thesis here, PJ. Two-word answer. Why do stars shine?
Radiation from the surface by heat energy created from the center of the star.
And now we're talking. They shine because they're hot.
They're hot. Yeah.
That is the answer. Stars shine because they're hot. Now, why are they hot? And we can get into that, but that's Wien's law. You heat something to a certain temperature and it radiates photons, yada yada.
I was definitely getting there. My next thing would be back body radiation, so that would take care of that. No issue there.
The last part of the icebreaker was so most people answer fusion. If the fusion ended, the star is hot enough, its internals are heated up enough, it could still have the same luminance for 150 million years. So
wow.
It might contract, God knows, but it might expand, but it has the internal thermal heat to keep it going for 150 million years. In fact, I think it was the 19th century, everybody thought that's why the sun was hot, was all the gravity, compressing the matter, making things hot. But they did the math, and it turned out the sun would only last 150 million years. And by then they recognized the sun was older than that. And that's how they came up with the, started looking into nuclear fusion and all. Anyway, that's nothing to do with my talk, but that's the icebreaker. Let's get into my talk. So, and by the way, right now you see the cover slide, right?
Yes.
Okay. So I retired in January, and I recognized probably a little while before that, I was nearing the end of my career and I needed something to do so I don't drive my wife, Leslie, crazy and all that kind of stuff. And I eventually ended up in this hobby, but I knew that I also had to do some programming, software. I've been doing software since I've been 20 or so. And, I'm a bit older than that now. So my first project was really take a picture of Andromeda with a SLR. And I did it just with the SLR, no mount, no tracking. I wrote the software to do the stacking and all that kind of stuff and star detection. And that wasn't a satisfactory way to do astrophotography, but it shows you sort of where I come from. And, I eventually met you folks and Glenn gave me a lesson at Little Uvas, and I learned a little bit about how to do this astrophotography. And I decided, I wanted to do a little more. I wanted to contribute software-wise to it. And I found this KStars project where it's available. That's sort of the reason I wound up in KStars as opposed to a Sequence Generator Pro or something else, is I wanted to find a project that I could muck with. That's just my, that's one of the things I get out of it that other folks might not. But anyway, that's sort of where I come from. But of course, KStars is a general purpose thing. So what I thought I'd do is, many of you may know about it, and so you can speed me up or slow me down, but I'll give a quick overview of KStars and then a couple projects I did in the last 4 or 5 months. I've made, just to say, probably 3 or 4 sort of major changes to KStars in the last year, let's say. I got into it about a year ago, and probably my first 20, 30 changes were little bits, add a menu item here, fix a bug there. But I eventually got to the point where I could start making changes, and most of the changes I made related to things that I found bothered me about it and I wanted to improve. So an example that I won't talk about today other than now is the stretching. Like when you see an image, take a picture, you see an image, they had a viewer, but it didn't do all the stretching controls and whatnot that you might have. And, I thought that was a place I could contribute and so on. So anyway, I found this KStars program, which KStars and Indi and Ecos has existed for a long time, right? I don't know how old it is, at least 10, maybe 15 years old as a project. And what's interesting about it for me, as I said, was the open source aspect of it. You could find all the software. You can modify the software if you could convince the people running the show that your contributions make sense. It's a standard package where you have your planetarium, your astrophotography package, lots of features. In fact, lots that I don't know about. Honestly, I use my sliver of it. Runs on several platforms. There are Windows users, there are Mac users, but I think the lion's share of the users are Linux. And it's sort of a forum-based thing, as many things are these days. But one of the things that I know confused me was all the names related to it. The KStars is the sort of the planetarium. Indi is sort of the device end of it. Ecos is the astrophotography part of it. But, I don't know, different people tend to refer to the whole thing with each of the names. And then there's different packaging of it. There's this StellarMate thing you can buy, which comes with a Raspberry Pi and the software. But, you can just buy StellarMate OS, which is the software. there's something you can Google. All the links are on this slide, which I guess you'll be able, if you haven't written them down and you want to see them, you could find it on the YouTube thing later or send us a note. Astroberry is an interesting packaging of KStars and several other programs. AstroPy 3 is a shell script that basically installs everything on Linux and so on and so forth. So there are a lot of names, and I don't know, I find that confusing. But, you know, in the end, just call it KStars or whatever. By the way, feel free to interrupt me. I welcome interruptions on talks like this. So if you have any questions, just let me know. So this is, I mean, I could have done this by going through the browser, but, you know, it's sort of safer to take screenshots in a talk. You never know what's going to happen. So this is a screenshot from a couple days ago of the, you can see indilib.org forum.html. It's the, you know, KStars forum, Indi forum, whatever. And it's pretty active. I try to help out there, you know, when people have questions. I answer a lot of questions, and there are a lot of people like that. You know, now that I'm more experienced with it, I'm sure at the beginning I was the one asking mostly, and now I'm mostly answering. But it's a good forum. You know, don't let it scare you. You know, when you look at it, you'll see bug reports. But of course, that's, you know, that's why often people post to forums, is because they're having some kind of problem. So I would say for the most part, it's reasonably stable. Here's this next page I'm showing you is if you know, search for the source code, you can find it. It's actually not on GitHub. It's on something called GitLab. But I think if you search for KStars source code or something, you'll find it. And, you know, you go in there, if you know C++, you could find anything, you know, everything and anything related to KStars. How does the guider work? How does, you know, capture? It may not be easy to, you know, I mean, it's a big, complicated program, but it's there. And for people, you know, software engineers or people comfortable writing software, reading software, you know, you can, if you work at it, you can certainly understand and make modifications. And just to show you, see, this page is the overall one. And I can you see my mouse over here? Okay, well, I'm assuming.
Yes, we can.
Okay, great. So over here, if you clicked on that, merge requests, you know, this is a copy of that page from a couple days ago. And you can see, you know, these are the changes that have been made recently. Or some of them, well, some say merged, which means they're now included in the source. Closed, I guess, means they were abandoned. And you could see, like, the top one is just a new feature that hasn't been merged yet, that Eric in France is working on. So, yeah, it's active. There's a lot of development in this, even though it's complete in the sense that you can do your astrophotography with it. But like anything else, there's new features that might be interesting, or bug fixes, or better tests. Eric there on the top often adds tests, which is something an end user might not see, but is really valuable for developers. Anyway, so it's interesting. It's an active thing. Oh, and then I didn't mention this, but this guy Jassim, I'm not sure how to pronounce his last name. Something like Mutlak or Mutlak. Jassim is the main developer or maintainer or whatever the word is. He's the guy in charge, and he's a really good guy, really smart guy. And you know, so if I have some ideas about something I want to change, I'll pass it by him. I'll eventually, you know, write the code and put in a merge request, and he's the one mainly who reviews stuff and improves stuff, and makes many changes himself. And he has this blog, Jassim's Ecosphere, where you know, mostly it's about KStars releases. You could see the last release in July was V343, and there's going to be a 3.5 coming up. An interesting thing about KStars is that so there is this stable release 3.43. It went through some testing. A lot of people use it. If you do the standard download software, that's what you'll get. However, there's something called a nightly release, which is just the latest software, whatever has been merged in. And that, so like I have a change right now that I submitted post 343, and users, adventurous users, let's say, can get it and test it. And that's actually very valuable. I mean, that's how you get stable releases, is somebody has to be the first or second or 10th person, using the software. And so there is actually a reasonably large community of people willing to test out the latest stuff and, complain on the forum if something's not working. And, these people are, very nice. They understand when there's a bug. Obviously, the developers try not to have any issues, but, it's just human nature. Nothing's going to be perfect initially. And it gets us to the point where we can, add features and have stable releases. So that's a valuable thing. So I'm just going to go through some screenshots of KStars. It has a basic, actually, I don't know if you noticed the background of my screen right here is the planetarium. And then this is sort of a zoom in of the planetarium where I have one of the, I think the SDS overlay on it. And you can see, it's this standard thing. It has a professional picture overlaid on the star locations. It has your something to show you your current field of view of your telescope camera combination, and so on. You can see a menu on top there for the various things you could do. One of the things you can do is this little dome here represents starting up the astrophotography part of the program, which is called ECOS. But before you do that, I should say that you'd have to, before you start all that, you'd have to configure what kind of hardware you have connected to your machine. So here you could see my setup, except I don't have a dome, but I opened up the dome menu so you could sort of see that. And there's a good variety of support. Indi is sort of an underdog. In the sense that manufacturers, that's not the first driver they write, right? They're going to write the Windows. I'm spacing. What's the name? Well, anyway, it doesn't matter. The Windows standard for interfacing hardware to these kinds of things. That's going to get written first, and then hopefully, if you twist their arms, they can write the Indi driver, or often the Indi driver is written by someone in the community. But anyway, there's a reasonable amount of hardware supported. And if there isn't, often people write it. So you configure your hardware. You could see in the upper left, there's sort of 3 tabs that exist without starting up the astrophotography, without starting up connecting Indi to ECOS. And I'll talk about one of them. But anyway, so the drivers are configured. And then in this screen now, I've started it up. I don't know if over here, and the screen was a start button. That's now a stop button. And it said, okay, connect to all my devices. I showed you the devices here. So then I hit the start button and I said connect, and poof, the devices connect. And now you could see I have a focuser, a filter wheel, a mount, a guide camera, and a camera all connected up. And this window here is sort of the driver's end of things if you want to change something in a driver. And then you have, the planetarium here, and then the ECOS astrophotography stuff here. So the way it's organized is you have these tabs that control different aspects. The mount is something you don't often control other than hitting this park and unpark button on the right. You have a few things you could do with it, like, make sure your meridian flip control is set, assuming you want to do that, or automatically park it in the morning, or enable various limits, or whatever. It's not a tab that's used a lot. Of course, it's good to set it up with the right aperture and focal length and that. I think I did this from my simulator So it doesn't have my particular focal length right, but whatever. Autofocus is an interesting tab, something I contributed to. Does the obvious. You know, here you could see a V curve, and it's come down here and back up, and then found an optimal autofocus point. Anyway, it does the standard autofocus. In this case, it's a full frame autofocus where it finds a lot of stars, finds their diameters, half flux radius, I guess, and minimizes that. You can choose, you know, to autofocus on a single star as well. It has plate solving with ASTAP or astrometry.net, online or local, and that works pretty well. I don't know. I tend to, I use the local stuff, of course. I tend to go back and forth between those two. Guiding is another thing. Actually, I'm going to be talking about guiding. You can use PhD2, and when I started with this program, probably until 2-3 months ago, that's all I ever did was use PhD2, and that interface works fine. Some friends of mine on the forum were telling me how they like the internal guider. I started using it. I saw some ways I could improve it, so I made some changes to that I'm going to be talking about tonight. So now I tend to use my stuff, but either way. And the capture is pretty standard. You know, you sort of set up a sequence of captures. In this case, you know, I'm alternating red, green, blue about every, I don't know what, this is a silly one because I did this, this is just my simulator, but I'll often alternate red, green, and blue, let's say a half hour of each, and autofocus on filter changes would be sort of my standard way of working. The scheduler, I tend to only have one sort of logical job a night, but a lot of times if my target is going down, or, you know, if your target's going down at 1 a.m. and you want to image the rest of the night, you could sort of, you know, set a schedule where you start out taking one target and then switch to another target, and you give it the sequence that I just showed you. You could give it the position you want it to slew to, and it'll automatically do all this stuff. I don't think any of this stuff is different than, or I mean, I'm not that familiar with Sequence Generator Pro, but I think it's similar capabilities to what you might see there, although I'm not sure about that. And then there's a FITS viewer, you know, so you take a picture, you can look at it, and you can open up other things, and there's zooming, and you can see these various controls at the bottom. And that's basically what I added, very similar to the PixInsight. I mean, in fact, it's the same algorithm as the PixInsight, sort of, what's that word, you know, where you take your linear image and you make it viewable. Okay. So, one last thing is, yeah, go ahead.
Quick question. I was just wondering, is there a built-in polar alignment routine?
Yeah, there is. I didn't mention it. Let's see. It's on the, you know, we may be able, later, we'll try to polar align if it's dark enough at the end. How's that? But I'll tell you that it's on the, because I do have my telescope hooked up on the hopes. Well, I didn't know if it would be dark enough when I was done. But you see here, we are on the, I'm on the plate solve thing tab, right? And if you look right, can you see the mouse? It says polar alignment. So right there is an automated polar alignment. Automated, what does that mean? What that means is that, you know, it assumes you're but pointing at the North Star. Doesn't do drift alignment. It does, you know, standard North Star kind of polar alignment. And then it'll take the 3 pictures, rotate the telescope, you know, by 30 degrees or whatever between each picture, and then come up with an offset, right? And then pop up a screen that shows you, you know, where you're pointing and where you need to be pointing. And then, of course, it's up to you to turn the altitude and the azimuth knobs. But you'll see, you know, you'll get visual feedback that you're getting closer to your target. And in fact, I use that all the time, or whenever I polar align. I used to use my PoleMaster, and anybody want to buy a PoleMaster, just call me, because I basically just use the KStars one now, or Ecos one now. All right. So the other thing I wanted to mention was it all runs on the Raspberry Pi. So there's me at GSSP, obviously not 2020, but 2019. And you could see the red lights coming from my Raspberry Pi. And it all ran there. Now, of course, I got a laptop there, but I was just VNCing into the Raspberry Pi. Or actually, I had a monitor too connected. I was, making sure that in case I lost Wi-Fi or whatever, I could still work. But the typical way that I interact with this is VNC over a hardwired cable when it's at home to the Pi, and everything is running on the Pi. I can close my laptop. All works. Some people use PCs or Macs or whatever Linux machines as faster machines that can do certain things faster. But it does work adequately, more than adequately, just on a Pi 4. I would say a Pi 3B, it was, hit or miss. I mean, it worked, but it was slow. The Pi 4, it's fine. All right, so that's KStars and the various other things related to KStars. And now I was going to mention a few things I worked on in the last little while. Before I do, I'll give you a few seconds. Anybody have a question about KStars or whatever that you want to ask before I change topics and talk about things I did?
Can you tell about the monitor that you have hooked to your Raspberry Pi? Is it a very small monitor hardwired to the Raspberry Pi? Is that what it is?
Yeah, I bought it's like an 8-inch external monitor I bought online for, I never use it, right? But I brought it to GSSP, right? Because, what if my Wi-Fi stopped working? But the truth is, I always VNC in from my laptop.
Well, I have had lost the VNC connection, lost the Wi-Fi connection, and a little monitor to get out of that emergency would be a handy thing.
All right, so Steve, I'll send you a link on what I bought. But
that would be great.
But the bottom line is, it's a standard. I found a small monitor that ran on 12 volts, so I could connect it to my battery. It's basically for remote, when I go camping, which is once a year.
And a little fold-up keyboard as well.
Yes, of course. Right. Keyboard, monitor, mouse, the package, right? A little hub, USB hub to put, anyway. Okay. And any other questions? All right, let's talk about, feel free to interrupt and ask, but I'm going to switch over now to a project. So the first project is a thing that I don't, tell me if it exists elsewhere, but I'm not familiar with this concept. But it was something to me that was just screaming to be built for KStars. Maybe SGP could use something like this. Maybe they already have it. And I called it the Analyze module. And I say it's currently in pre-release. Nightly's meaning it didn't make, I wrote this or completed it after that 3.3.4 release. And so it's in the code base. People who, either download the code, or there's a nightly build of the code that you can get and just download. So people are testing it, and it's gotten good feedback so far. And before I get into it, let me mention, you could see here, this is an Indi forum name. Hi. Somebody should mute or talk, one or the other. Okay, so when I've introduced several new features, and whenever I do it, what I do is I post on the IndiLib forum and say, hey, I got this new thing. And, if you're using Nightly's, please test it out. And so you could see, here's a post that you could find if you went to that forum. New KStars Ecos module called Analyze. And it's longer than what you see here. And I sort of described what it was and, tried to give a few, instructions on how you might use it. And, obviously I'm looking for bugs and feedback on how I can improve it. And it's interesting. Being, at a certain age, I wasn't used to that way of dealing with the world, but that's obviously the way things go these days. And so that's yeah.
I'm sorry to interrupt. Is that a screenshot? Can you scroll up a little?
You're going to see all the screenshots later. So what I'm showing you is a screenshot of my forum post.
Got it. Okay. Thanks.
Yeah. So next slide is, don't worry about it. So here you go. Next slide, screenshot. So this is the Analyze tab. So you can see on the top of the screen, there's the various tabs, right? And the three on the left, which is mine, and the third one is mine. These first two are, how you connect to Indi and the scheduler. And then the five on the right are the ones I went through earlier, capture, focus, mount, align, and guide. So this is mine. You'll notice mine is the only one without a professionally done icon. So, so I just went into Photoshop and sort of hand drew a little graph there. And hopefully someday I didn't even mention this, but KStars is part of something called KDE. I don't actually know what KDE stands for, but KDE is this organization that has a number of open source software projects under it and provides support for them. And KStars is one of them, but there are many. They do, so they I'm sure pay for the Indi lib, GitLab, hosting of the project, and they have all sorts of software libraries, and there's sort of ways to write the software or the user interface that you conform to the KStars, the KDE methods, which is good. And anyway, and there are a lot of volunteers there that deal with things like making sure things work in multiple languages, and you do the internationalization right and the documentation and whatnot. So that's a very valuable thing. So KDE is important. But anyway, below KDE is KStars. So KDE has, I know there are volunteers there that do, design, that are talented artists, and hopefully I'll get a little icon done. So anyway, this is the Analyze module, and this is the one screen, really. There's only one screen. And what you see here is first the top section, that says mount, flip, guide, align, focus, and capture. That's a timeline. So it shows you what's happened so far tonight, or you can go back and look at yesterday's or last week's or last month's sessions, right? So it stores logs, specialized logs that you could look at, but let's pretend that we're in the middle of capturing. This is actually read from a file. You could see that on the top line. It says, it gives you the time when this log was written, but it could also have been the current session. And you could see, we're, almost 2 hours into it, and so on and so forth. And it shows you what happened. So we did 8 green captures, followed by, first we did I don't know, it looks like an HA. I can't click on, let me go back. Some kind of focus with some kind of filter. Then we did a green focus. Then we did 8 green captures, a blue focus. I hope this is clear what I'm pointing at. And then a blue capture, another blue focus. God knows why. I don't remember why, I just went back and took one of my logs. Maybe I was playing, I don't remember, and so on. So you could sort of see what happened there with respect to captures and focus. Align, there was probably a meridian flip and an align, but maybe we're zoomed out too far to see it, since those are pretty quick. There's guiding sessions that seem to be interrupted by dithering, or focusing. Here's the meridian flip. And there's mount, basically tracking sessions. So this whole thing sort of gives you a view of what happened tonight, this night, this guiding session. My idea was to make it so that you could, did things work out, and better than, I don't know, the way when I would image, I would never be 100% sure how things went until I looked at all my images and yada, yada. And this at least gives you some kind of view on that. And then the next session, called statistics, has a whole bunch of stuff you can plot. And I probably should add another 6 or 8, but this is, what I did on V1.0. And what only a few of them are checked right now. So what's checked right now is the yellow, which is the SNR from the guider. So the signal to noise ratio of the guide star. You could see that at the end there, the signal to noise ratio was taking a dive, right? Clouds were coming in, let's face it. This change in signal to noise ratio at the beginning most likely has to do with a change in guide star. I'm guessing that there wasn't a problem. But anyway, this is the kind of thing you're going to look at the plots and learn how to interpret them. The blue line there is the HFR of the image. What that really means is it takes 100 stars in the image and it computes, their half lux width or radius and averages those 100 or something like that, comes up with a value for the image. And, the tighter the star, the smaller the half lux radius for the stars. I mean, it may be relative depending on your equipment, but again, you could see imaging getting a lot worse at the end, when the skies are getting iffier. The red line is it's the RMS guiding value. There's this funny thing I'm going to look into. You can actually see it here. Let me point out that I've clicked on one of the guide sessions here, right? On one of the captures where the arrow on top is pointing. And when I click on that, what that does is it displays the guiding, what's called a drift plot in KStars, which is, all the guide error values. And those two circles are 1 arc and 2 arc seconds. And it's showing you the values. And you can see at the beginning, the first 3 samples after the focus, it had drifted out. It had drifted away. And then it started guiding. And that spike in SNR has to do with those 3 samples. It may even not start capturing until that is below 2. I think there's an option for that. And that I may or may not have right yet in the analyze module. But anyway, you get the idea. Let's say this was a problem. This would have alerted me to it and I could look at it. So there you go. When I click on the capture session, it also gives me some statistics about, when it started, when it ended, the filter that was used, yada, yada. And, this is dependent on the thing you click on. I don't know if I have it here. Let's see. Yeah, see, you can click on a focus session and then it'll show you, I've set it up to where it could show you the V curve from that focus. And you could see, it got down to less than 1 arc second HFR on the focus, which is good. And it gives you some statistic. It took 90 seconds. A lot of people complain about my focusing software that it takes a long time. I always say, why sweat 30 seconds when you're going to image with it for the next hour? I don't understand. But anyway, there you go. Different point of view. In any event, so you can click on different things and get information. The most interesting things to click on are if you double click on the capture, I don't believe I have this in this presentation, but if you double-clicked on the capture and it has the image still on disk, it will show you the, it'll pop open a FITS viewer, which is the KStars display program for FITS files. And you can look at your image. The focus information I told you about, guiding more or less just shows you a drift plot and some guiding statistics. And the other two aren't that interesting yet. And I don't know, I'm wondering about if there are other things that might be interesting. I don't have a dome. I haven't had, it would have been hard to debug that, but there's probably dome statistics and things like that. There's a cursor. Oh, well, let me see what I have in the slides here. So yeah, here I clicked on, obviously I have now RA pulse and DEC pulse. I could have added the actual RA and DEC errors. In this case, it's the correction pulses, which is a similar kind of plot. And you could sort of do that and zoom into it. And in this case, I've also zoomed into the HFR plot. So you can sort of, I don't know if there is a difference between 1.4 and 1.7, there might be. And so you could sort of see it was a little rough at the beginning. Maybe that was early in the evening. Well, it's 11. This is 11 p.m. right here. So it was probably not that early. In any event, there you go. So you can get those kind of statistics as well. I told you about the focus session. And okay, so here's guiding where I've clicked on the RA error, which is the brighter line. So the bright green, I believe, is RA. Yeah, you can see that from the legend here. So I believe anyway, and the blue, the bright blue is the, I believe, by the way, this software, you probably, no, it's okay. I had a bug in there where it was plotted wrong. The guide pulses, obviously should be opposite the errors. In any event, so there's that. And the other thing to notice, by the way, I don't know if I didn't call it out, but I zoomed into the graph, right? So you can zoom in from a time perspective as well. So now it's only showing, 900 seconds on top instead of a couple hours on top. So you can zoom around in both, the timeline. Well, these two plots are coordinated. These two graphs are coordinated. They always show the same time interval. And you can zoom in. And another thing on top is this latest button where if it doesn't apply for reading from file, but if you were imaging and looking at this screen, it would always, stay up to date. So as time advances, the screen will scroll and you can choose the width that you want. Here's an example where it zoomed in on the meridian flip sequence. And so I believe this yellow line is the mount was ready. The mount module decided, time for a meridian flip. The hour angle is, I don't know what, a little bit past the meridian. Let's flip. Yellow means waiting because you could see there's a capture that was ongoing when it decided that, and it doesn't interrupt the capture. So waited till the capture ended, and then you could see the mount started slewing. I mean, you can't tell that, but I don't think I have it here, but in the real program, if I clicked on that, you'd see it was a slew. And then you could see a bunch of slews and the align module activating and plate solving, and did a little iteration on that until it found just the right spot and then started tracking again. So you could examine things like that. At this point, I'm not 100% sure it's not just eye candy for something like the meridian flip, but we could probably add enough statistics if stuff is missing where it really could help you understand your system better and be more effective at using it. So I mentioned there that you could read from files. So you could look at your old logs and see how yesterday's session went, and maybe compare yesterday's and today's and stuff like that. Again, this over here is this is the 0102 means it was 1 a.m., 102 a.m. and 7,074. That's how many seconds into the start of KStars, or at least the start of Analyze that it was. Okay, so let me stop there for a second. And that was the Analyze module. I have one more thing that I did. Whoops, sorry. I meant to go to a different screen, not to do that to you. Okay. I meant to do this so I could see your faces. And I'll leave that on the screen. Are there any questions about analyze, or is this like obvious and SGP's been doing this for 15 years, or I don't know what, or is there something I missed, or anyway, that's my question to you folks.
I think it's nice work. The point of it is, I guess, is to know whether things are going right, and if they're not going right, what went wrong. I think the way you've brought everything together in one screen so you can quickly see where the problem is, I think that's great.
Thanks. Yeah, I mean, my idea was that, you know, most people in this hobby are tinkerers, it seems. And, you know, and so I figured to give you a tool to tinker with. I think it'll certainly generate more complaints on the forums, but I guess that's good. Any
you know, I think this is pretty fantastic, actually. It'd be great for debugging stuff. And the only thing I don't see here is maybe eccentricity of the stars, or am I just missing that?
No, it's not there yet. It's certainly on the list. I'll tell you just offhand. The reason it isn't there is one of the other developers, Rob Lancaster, is he's in Delaware. He's one of the other people who work on KStars, and he's doing an overhaul of the star detection module and the plate solving. I'm not module, but the libraries that are called, and the plate solving ones. And I didn't want to sort of start getting into you know, like making changes to, you know, because eccentricity isn't something that's available right now. And
Sure.
It's a small change. I mean, you know, in fact, it's a 3-line change, and I know how to do it, but I just sort of avoided it on V1.0 for that. But I agree with you. I tell you what, though, I think one of the problems is I already have 18, or God knows, not 18, but a lot, maybe 16 checkboxes there. Some of them are ridiculous to plot, but are interesting to look at in terms of their numbers. You know, so I'm going to have to deal with, you know, eventually there's going to be 30 or 40 values to choose for plotting and yada, yada. And that is a complexity, is how to do the user interface for that. Oh, and there's one more interesting user interface constraint. Jossam insisted, and I think he's absolutely right, that it has to work on a relatively small monitor, you know, low resolution. So I think the constraint was something like 800 across and 750 up, down. And so, you know, this is the kind of a tab that's, you know, screaming for 2000 by 1500 or something. But yeah. All right. Any other questions? All right. Well, anyway, feel free to, you know, post to, you know, either send me an email if you have my email, or post to the SJAA observers email list, and I'll read it. And send suggestions. I don't think there are a lot of KStars users at the SJAA, right? But, you know, so maybe it doesn't directly apply to you. I mean, obviously, if you are, you know, I'd love to, if you have any questions, I'd love to help out. But anyway, it's an interesting way to go, this analyze thing, I think. I use it all the time. All right. So the second topic is guiding, and as I said, I used PhD2, and you know, like a lot of PhD2 users. And by the way, PhD2 is an excellent product. So or whatever you want to call it, product. It's free, but you know, software, piece of software. It's excellent, and I used it for a long time and enjoyed it, and it was great. But, you know, like everybody else, you know, I would fret about my guiding, right? I mean, who doesn't? And so I had this idea that I could improve the guiding by, oh, I lost the slide I wanted. I guess it's gone. It's funny because I used it as the master slide. You could see how my slide is grayed out. And somehow I got rid of the main one that had them all in black. So you can see, I'll put this one up. Sorry about that. So well, let me just go back to the main thing. So I had this idea that guiding, that I could do better, that seeing was messing with my guiding, right? And everybody, I mean, of course that's true. And seeing messes with everything, certainly messes with guiding. And I had this idea that, you know, if you guide on more than one star, and I'm not the first person to think about this, that maybe that could improve the guiding. So, you know, already we're doing, you know, we have the star detection software. KStars, by the way, gives you the option of using a number of you know, you take the guide camera takes a picture, and you can, you know, something has to obviously find stars in that picture, and then, you know, does the feedback to do your guiding. And so there's already star detection there, and you have a choice of 4 or 5 algorithms to do that. And one of them is S-Extractor, which is a sort of professional astronomer software. And Sep, S-E-P, is the library version of S-Extractor, which is the, I guess, the program. So Sep, or S-Extractor or something, is the module that I'd been, you know, the version that I'd always been choosing. And Sep was already detecting all the stars in the image. So I thought, what the hell? Let's guide on more than one star. And let's say, you know, you pick 10 guide stars, you could find their average error and, you know, push the mount in the direction of the average of the 10 error instead of 1. And this isn't a, you know, I'm not the first person to have the idea of using more of the image to guide with. And there's other approaches to this. There's, you know, like overall image analysis versions of that as well. But anyway, it was straightforward to add multiple stars, and I came up with this Sep multi-star guiding idea. And I implemented it and tried to get it to work. And long story, this slide isn't the slide I wanted to show you, but you'll see why I have it there for a second. In a second. In the end, I implemented it and I started guiding, and I couldn't convince myself that I had improved the guiding substantially. I mean, maybe I had, but I couldn't prove it. Guiding is sort of hard to prove that you've improved something, you know, because conditions change. You know, you can't guide with 2 algorithms on the same night, sort of. You know, you're guiding with one or you're guiding with the other, and then you try the other one tomorrow night, and unless it's radically different, you know, if you changed it by a little bit, it's hard to know. That's one of the issues, I think, developing for guiding. So I wasn't 100% convinced that I had improved things. But interestingly, I was having trouble, for whatever reason, I was having trouble. I would lose my guide star a lot. And it occurred to me that with this multi-star approach, do I have a picture of it here? Let me find a picture of it. Here it is. Let me show you this picture. So this is what I wound up doing. You could see here, this is, by the way, simulated image. Unfortunately, you know, Bruce and I talked about doing this talk, and I, last week, and, you know, since last week, there's been no imaging here in the Bay Area, as you're all very well aware. And so I just made this slide from the simulator, but same idea. Yeah, KStars has a simulator, which is really useful for writing software, debugging software, testing software. So here you could see a guide image, and it's selected, I believe, 10 stars as potential guide stars. It's actually picked one as sort of the real guide star, the one in the square, and the other 9 are circled. But my idea was that we would track them all. And like I say, guide using the offsets of all of them. And as I was saying, I did that, and I didn't convince myself that I had improved it, although it's possible I had. But what I realized was, well, you know, they're at a certain offset to the guide star, right? There's a certain pattern here, right? You have a star, our friend the guide star, and then to the right of that, and slightly down but pretty close, is another star, and then down 30 degrees and a little further away is another star, and so on, right? And there's this pattern in the sky. And probably, at least for this image, you couldn't find, like if you shifted that square and put it on another star, you wouldn't find a position where you'd find all those other stars just in the right place or within some small error, So this pattern you see here sort of defines the position of the guide star. That occurred to me. And because of that, it occurred to me that, hey, this would be a better guide star finder. Like the way the guide star finder worked before was that, it had a sort of rough area of where it was. It assumed it didn't move much. And so it just looked in that reticle and looked for a star. But what if there's 2 stars in that reticle? It might pick the wrong one. So, well, with this algorithm, it would do better if there were 2 stars in that reticle. It would pick the one, where the, unless you got really unlucky, this is going to tell you which of those 2 close stars is the guide star. Now, of course, it may not be the smartest thing in the world to pick guide stars, right next to other stars, but this is a general problem as well. So it occurred to me that the same Sep multi-star approach that I used would be good for finding guide stars. And perhaps, and so selecting. So anyway, with that in mind, that's it definitely improved things to do that. I discovered right away when I was having trouble keeping my guide star, I switched to this algorithm and no problems whatsoever. So with that introduction, let's talk about the various steps in guiding. So if we look at the left and ignore the fact that I've sort of grayed things out, I intended to have a slide where this was all dark. You could see that the steps are, select the guide star, calibration, where you move the guide star around, and you see, a few things. You find out the RA and DEC directions. If you haven't thought about it, your image, the RA or the DEC direction, it can be at an arbitrary angle in your guide image. It depends on how you rotate your camera, you rotate your telescope, yada, yada. So it can be at an arbitrary angle. Now, it keeps that angle throughout your imaging until you rotate your camera, but it is at an arbitrary angle. So you need to know that. And, because let's say you want to move, you're off. Let's say the guide star needs to come down by 2 pixels in the main image. Well, how do you move it down by 2 pixels? That may be some combination of pushing the RA in a certain direction and pushing the DEC in a certain direction. So you have to know the directions that they're pointing. So that's one of the things calibration does. Usually, almost always, RA and DEC should be orthogonal at right angles to each other. But still, you need to know that. And they can flip. And also, a certain push on the RA motor can, you have to understand how much that affects, like if you push the RA motor for half a second, how many pixels in your guide image will that move typically? So that's another thing that calibration typically does. It determines those 2 things, the angles and the sort of the gain of the, in pixels of the RA motor and DEC motor. Then it guides, and in guiding, you capture an image, you locate the guide star, you compute offsets, how far things moved, and then you push the thing again, and then you iterate. And then there's dithering, which is a whole separate topic. That's not that relevant. But let's get back. So I had this idea for Sep multi-star. So select the guide star. I added this Sep multi. Anyway, here's my new algorithm. So the first thing it does is select the guide star. I actually did update the algorithm for finding a guide star. There was a heuristic there, and I changed it to basically the signal to noise of the guide star. Finding a star with a good signal to noise, the maximum, but not too high, because it tends that the things in your image that are have monstrous signal to noises tend to be, galaxies, the middle, the core of Andromeda and stuff like that, which you probably don't want to guide on. So, within reason, selecting a guide star is finding a high SNR star. And in this case, it finds, 9 other pretty high SNR stars in the guide image. And so, here's a table. So you could see this is the output of the Sep algorithm. You could see there in the background table, it finds 100 of them. It picks 10. In this case, it rejected the real high one, saying, well, maybe that's a galaxy or something bright that's a little too broad. You could see it has a high, it's not a ridiculously high HFR at 4.6, but it's higher than the rest. So I wound up picking 1 as the guide star. And this is the collection of 10 stars it's going to be using for its multi-star algorithm. In calibration, moves things. Now that you have a guide star, let's say it moves the, I forget if red. This is, by the way, a PhD 2 picture, since again, my stuff, couldn't get it for my stuff this week. But same principle, you pulse the RA motor, it moves, you see where the star moved to, you keep going. And from that, you find this direction, the RA direction. This is, I guess, the positive RA direction, and then it'll go back, and then you do the same for DEC. The lines are pretty close to 90 degrees. They're not exactly, you could force the thing to be 90 degrees, or you could just take the lines you got, since you don't know exactly what the truth is. And of course, the number of pulses tell you, if it took this many pulses to go this distance, you sort of have an idea of what the gain is. How many milliseconds of pulse leads to how much movement on the image. So I made some changes to this algorithm, mostly. Well, in fact, we weren't using the gain at all. There was sort of a hard-coded gain, and so I changed that. I added the ability to remember calibrations for future sessions. PhD 2 does that well, but KStars hadn't done that, and so on. And then I did the obvious, the multi-star business, where now it looks at all the stars and finds the offsets. And in my case, I guess I wound up picking the median change in RA and the median change in DEC and calling that the error, from the desired locations. And adjusting the pulse such that it went back to that. And the one thing I didn't change was the actual feedback algorithm, the control algorithm that's used there. Oh, you know what? What do I mean? I actually did change that. Glad I had this slide. You could see here, I was thinking of changing it, because, like, again, I was fretting over my guiding, and I was, anyway, I was bothered by it. And then I know PhD 2 had this really good algorithm called, what's it called? I forget what PhD 2 calls it. But they have an excellent RA guiding algorithm. And I discovered that it was actually written by, it was a PhD thesis, nothing to do with PhD 2. It was a PhD thesis out of Zurich. And so it turns out it's open source, and it's not just PhD 2. So I found this guy, Edgar Klensky, and Edgar allowed me to use it for KStars. So it's the, I wish I could remember what it's called in PhD 2, but it's the same code, same algorithm integrated into KStars. It's a really interesting algorithm in that it basically estimates the periodic error in the mount. So that's why it's only applicable to RA as opposed to DEC. But I added that code in. I didn't write any of this code, the algorithm code, but I integrated it into the ECOS program, which had its complexities. And then I did what I just said earlier, which is to post about it, and that is in the 3.4.3 release, and it's got a lot of use. And in general, I think there's been good feedback that the internal guiding has improved in KStars. It's probably, I don't know. I can't evaluate it. I would love to evaluate it, but I don't quite know how to, quantitatively say it's, 15% better or whatever. In any event, yeah, go ahead.
Would that be low pass or
No,
not resist switch is for deck only, I believe. So
it's not low pass. No. You're talking
Predictive.
about exactly.
Predictive
a predictive PEC. Okay.
Right, predictive PEC. It is exactly predictive PEC. It's the same source code. I mean, there may be things in PhD2 that they do on top of predictive PEC, but the predictive PEC code is the same code. Okay. Which is an excellent algorithm. It's an interesting algorithm because it improves, right? Like the first 15 minutes aren't as good as the next 2 hours. And then if you move the mount, you start over. So it's interesting in that it improves, but it definitely improves. One of the things I was talking to Klensky about was, could we, the reason it resets is because, it's modeling the periodic error. And so it has to sort of know where in the period it is, because it now has a model of, I'm at this part of the period. So I'm expecting, the RA error to be a certain amount. And so the adjustment I make is going to take that into account. And when you move the mount, it loses that information. But, some mounts have the encoder available to the software. And so in theory, it could know where it was and pick up where it started from. Anyway, I started talking to Klensky about that, and he was discouraging it, sort of saying it's complicated. I mean, you could do it, but it's complicated. He wasn't discouraging it, but he was just telling me that it was more complicated than just throwing in the encoder number and poof, I would be done. So, so maybe it's a future project. But anyway, he was very helpful, and I do believe that improved my guiding, at least, qualitatively, it seems so. Anyway, so that's, that was, 3 months working on the guider, I would say. And then I did a whole bunch of other small changes you could see there. It keeps me busy. I'm retired. Keeps me out of trouble. The challenges and almost all this stuff, I would say, are data, like, as I say here, it's easy to think of something, exciting and new to do, but how do you know that you really improved anything? And honestly, I don't have a good answer for that. I really don't know how many users are using either of these two things. I really wish I did know. I do, when I write some new software, I find a buddy on the forum. I find somebody who's interested in a topic. I send him a note. I say, hey, you're having problems with, guiding. I'm writing this new guider algorithm. You want to test it out? And I work with this person or two or three. And I try to, make sure it works really well for them and for me. But, I don't have a view of 100 people doing that. And that's what you really need. In my professional career, we were able to get data and feedback on how our products were working. But for this, it's not as easy. You can imagine putting some kind of, by the way, I'm going to stop sharing and just go to my camera, I guess. Because that's the end of the presentation. Yeah, I'm sure there's privacy concerns about, just like having KStars, ship your, whatever usage statistics up. Maybe we could do that, with a default off, but you could click to turn it on. But I would say getting data on use and getting data on, are things improving is a key challenge for this kind of program. And a lot of what I've done was sort of, intuition, and hopefully some of it worked, but it would be good to know that better. I wonder if other programs have better access to that.
I would expect that if you are on a thread for KStars on cloudy nights, for example, you get a different audience than the KStars forum itself, and maybe you might get some more people to be interested in KStars and also to test out your parts of KStars for you.
Yeah, I can get testers, like I say. I typically get 2 or 3 testers for a feature, but I meant like large usage statistics, like getting understanding guiding from 100 people. When I worked on speech recognition, we would have 50,000, 100,000, 1 million test things, and we would make tweaks to the algorithms, and we would see it improve. And self-driving cars the same way. We had millions of miles of driving, and we changed the algorithms, and we could see if they improve things or not.
Sure.
And here it's a different animal. Okay, any other questions? If you're interested, Bruce, I could try to what's the word, polar align or something like that.
Sure. Let's see if you can see a star at this. I looked at
You
clear
think it's
outside. It didn't look very good.
Well, I'll tell you what people, whoever wants, talk, and while you're talking, I'll see if I can do that. I'll share my screen, and I'll be doing that as you're talking. But I lost my VNC. Let me go find my VNC. So any other questions? All right. Well, look, I assume everybody can see my Raspberry Pi.
Yes.
Okay, good. All right. So here I am, and this is a little KStars window, and I'll click on the dome there, and that opens up ECOS, which is the astrophotography thing. Here, this connects to my devices. Something's going to fail now, but nothing has failed yet. I'm trying to unjinx it by saying that. You figure if I say it's going to fail, it's a demo syndrome. Okay, so we find the target. Oh, the first thing you got to do, I don't know why it doesn't do it itself, is unpark. So I'll unpark. I tell you what, let me just take a picture just to see if we can take a picture. Probably HA is not the right filter to use. I'll take a 10-second picture, and if we can see something that sort of looks like the North Star, then it's worth trying this. So I just hit the preview button, right? It's not, so I didn't need to set up anything fancy since we really don't care. And yeah, look at that, a North Star. All right, so so far so good. So in theory, we should be able to polar align, or at least get the polar alignment error, right? So I go to the align mount. I click polar alignment. I think I just hit start. You could see that I've already had it set up to 30 degrees west is the rotation it's going to do for each of the 2 rotations. It slews fast. Why not? And I hit start. And so I don't know. Can you see the bottom? It says capturing image in this log window. Here. Okay. It captured an image. It's now plate solving. You can see that I have ASTAP set. Oh, that was pretty quick. Now, ASTAP is a very quick polar aligner. All right. It's capturing the second image. It had rotated. There it is. There's ASTEP. It's quick. How about that quick plate solving? Remember the days when that was like a minute?
ASTEP is the fastest plate solver out there, from what I understand.
And this is a Raspberry Pi, right? I mean,
That's impressive, really.
I didn't catch the name of the plate solver. Can you spell it for me, please?
ASTAP.
Okay, thanks.
Okay, so here you see the screen, polar error 1 minute, 18 seconds. You see that, Bruce?
Yes.
Okay, so then, I mean, obviously I'm not going to be able to turn the knobs, but let me show you what you would do. So what you do is you make the window a little bigger, because damn it, that window's too small. Find something that you want to move, so you find a star. I'll click on the North Star, and we'll just zoom in there, right?
So once it knows what your polar alignment error is, anything that you can see on the screen can be used as the point of reference to get back to?
Sure. Right. So it's telling me, well, maybe I shouldn't have picked that. Maybe, in this case, maybe it's too fuzzy. Since we're so small, I'll pick this star. And so you could sort of see, I mean, maybe, you want a reliable star too, but, and in any event, who cares? So I'll put it to the middle and zoom in some more. And, there you go, right? And so at this point, let's say this is set up enough. Then I'll get it. One more. Then what you do is you hit next here. And then, one second. I think you hit refresh. I don't know why I don't remember. Okay, so yeah, you see it's taking pictures now. I mean, that star is sort of, it's not the brightest star. I probably should have picked a brighter star. But anyway, it's taking pictures every second or so. And, you turn your knobs until that star moves to the center of that target. Now, me being off 1 arc minute, I wouldn't have touched it, right? I would have said 1 arc minute, fine, I'm done. I don't need to try to make the polar alignment, I mean, I don't know if I believe it when it tells me it's 15 arc seconds anyway. Anyway, that's it.
Very nice.
All right, I'll stop sharing. And there you have it.
Anybody have any questions?
What's the effect of seeing relative to the 1 arc minute error?
Well, somebody else want to take that?
Well, anything less than 5 arc minutes is generally considered to be adequate, I believe, but 1 arc minute is definitely very good.
I mean, seeing it like a few arc seconds, right?
Yeah, it's a different order of magnitude.
Right. So, I mean, but this is polar alignment. But anyway, yeah. So,
I mean, the seeing will affect as you make adjustments. You'll see your star move around a little bit if there's, if the seeing isn't really steady. So it might be slightly less accurate, I suppose, but it's going to average to the same, to the center of what you're trying to adjust to, probably over time, I suppose. Is that correct, Hy?
yeah, I mean, yeah, I think the seeing errors is small. So don't worry about it. And yeah, I think people fret about polar alignment a little too much anyway. I mean, like Bruce said, I don't know, I would have probably reduced it if it was 5, but 1 arc minute seems probably plenty. Now, I don't have, I don't know, does that change when you have a longer scope? I mean.
Well, I have a question. Does your algorithm take into account atmospheric refraction?
Which algorithm are you talking about?
The polar alignment one. does it take into account atmospheric refraction depending on the altitude of what you're tracking on and the altitude of where the North Star is?
Yeah, honestly, I don't know the answer with respect to KStars. I didn't write it.
If you're using a section to locate your location, that is like a big deal in doing those sorts of things. So I just wonder if someone had incorporated
I know Polemaster definitely does that.
What does?
Polemaster.
T-Point also does, and I think that there's a selection in SharpCap that you can choose to do refraction in the settings for SharpCap, I believe.
Because the tracking will vary depending on the altitude of the star that you are tracking.
I think
And
that the
there is going to be the North Star, but anyway, I'll tell you what. I'll find out and I'll send you a note.
Yeah, I think PJ, I think
project for you to get into.
I think the thing, PJ, may be that your tracking may differ depending on where the star is that you're trying to track.
Correct.
Or alignment might be different, but it's like T-Point, I believe, averages it based on the atmospheric refraction, but when it does a T-Point model. But a T-Point model is constantly changing its tracking once you enable it for ProTrack, as opposed to something like this where you're doing one polar alignment, basically looking north, and I don't believe that it can apply different tracking rates at different points of the sky.
yeah,
So I would
think
say
that's
it's
exactly-
limited in that way.
With the software BIS mounts, the T-Points things would take into account the refraction effects.
Right, because you're playing back a model, and it's looking as you move your mount to different parts of the sky. It applies the model locally to wherever it is that you're pointing.
Yes, but he's taking into account refraction effects because the apparent position will change. Stars in the sky do not describe perfect circles in their paths as the Earth turns underneath them. Their paths are affected by refraction. So
But
that's
one,
just an esoteric thing to discuss. It is a real effect, but if you're shooting above 30 degrees most all the time, like most of us are, it's going to be pretty much negligible. I was just wondering if someone had gotten into that.
but going back to the accuracy of the polar alignment, the PhD2 authors told me that it's actually advantageous in terms of auto guiding to not have a perfect polar alignment. It helps some of the algorithms to be a little off. I don't have the technical details, but that's what they explained to me.
Flash in the declination part, especially, that's what a lot of that's about, keeping the gears loaded and stuff like that.
Yeah, that rings a bell.
Yep.
And it causes it to correct in one direction rather than back and forth.
Which is another way of saying the same thing, I think. Yeah.
Right?
Yes, we are dealing with mechanical things and not theoretical.
Any other questions?
Well, I want to know what Francesco's imaging.
I'm 27.
Well, it's bright enough to get through the smoke, that's for sure.
Well, yeah, exactly. It's
not very smoky right now.
It's there's very nice seeing, most importantly.
Excellent. Okay. Is there a armchair star party coming up, Glenn? Do you have any details on anything coming up?
I do not. I haven't heard anything.
I haven't either. Okay. All right. Well, thank you everybody for coming. Thank you, Hy, for excellent presentation. Actually, I am looking forward to trying ECOS and KStars.
Well,
So
certainly anybody who wants to try it and is having any issues, like any program, it has a learning curve. So obviously feel free to reach out if you have any issues. And
I have a small question. Does it work with ASCOM or it's separate from ASCOM?
oh, I think that was the word I was looking for, was ASCOM. Indi is, a replacement for ASCOM, right? It's separate. It's the same functionality. And so, no, it doesn't work with ASCOM. It uses Indi. And that's what my point was, that drivers tend to be written first for ASCOM. And then, so I think maybe the struggle of the ecosystem is, doing that. But I think more and more, almost all the new equipment coming out has an Indi driver.
Yeah. Actually, there is a big push to kind of get out of ASCOM recently, because everything goes to ASCOM. Yeah.
ASCOM also, ASCOM 6.5 is the first version of Alpaca, which is distributed, I guess you'd say, way of
remote,
doing this.
I guess.
Yeah, remote control of different things in your network. And
has anybody messed with that, with the Alpaca stuff?
I did early on when it wasn't fully working, and just passed over it from there. I haven't gone back to it since it's been released, but I'm not sure I'm buying into the concept. It seems like you're adding points of failure, right? So just so people are clear, what it would allow you to do, for instance, is you could run SGP or whatever, let's say whatever uses ASCOM that you like to use. You could run that on a computer in the house, but then have your devices out on the telescope computer talking across the network. So it's sort of a little different than doing VNC or TeamViewer or something, a remote desktop. But as Hy mentioned, if you're doing VNC and your laptop dies, it doesn't matter, because your Raspberry Pi out on the computer is still going. But in this case, if your computer that you're running SGP on dies, then you're done. So I don't know that it's a good idea or not, but
it's classic Windows updating in the middle of the night.
Yeah,
killing
exactly. Two Windows computers instead of one, I guess. But
Indi had the same concept, right, of running Indi on multiple machines. I mean, it has that concept.
Yeah, it does. Yeah.
But honestly, I never run it that way, right? Some people do, but yeah, it seems to me like one computer imaging is,
well, if you thought your Raspberry Pi wasn't powerful enough, right, it could be just the Indi server, and then you could have a more powerful computer as your Indi client, or whichever way the syntax goes. But yeah.
Hi, actually, I have another question. You went to a Raspberry Pi 4, I don't know, a year ago, and what do you have to say about the Raspberry Pi 4? Other than I remember you needed a heat sink, and
what do I have to say about it? I mean, it's a lot faster than the 3B. So it was a big improvement, and probably the biggest part of that improvement was going to 4 gigabytes. 1 gigabyte is just, it's not a modern computer if it only has 1 gigabyte of memory, right? That's just too little memory.
Sure.
The Pi 4 with 4 gigabytes, is usable. Is it a fast computer? No, right? It's probably the slowest computer you'll have in your house, but it's acceptable for it can run all this stuff. You saw it run plate solve in a few seconds, right? So it's
1 second.
Okay. So maybe that was an easy plate solve. I'm not telling you that all of mine are that fast, but it was a real plate solve on my telescope. So you can definitely do this stuff on a Pi 4, and the advantage is it lives on your telescope, and you don't think about it, and it doesn't reboot in the middle of the night and all that. Am I tempted to buy a faster computer? Sure. You know, I mean, it seems ridiculous that, you know, people spend all this money on equipment and then insist on spending $50 for their computer, right?
Well, there are happy mediums, I think, that will run Linux and be low power consumption, but twice as fast or more as a Raspberry Pi.
Right. So does the Pi work? Yes. And the Pi is ubiquitous, and so it's supported well. And, you know, there's a lot of, you know, the software is going to work better on it than some computer that is twice as fast, but nobody uses, right? So anyway, you get the idea. It works, and it's what I use. Sure, it would be. I don't develop on it, right? Not at all, right? I develop on my Mac. I run a virtual machine, Ubuntu, on my Mac, and, you know, all my compiling, my initial testing, everything runs on my Mac. I get some code that's, you know, and by the way, the compile is an order of magnitude faster. And I kid you not when I say an order of magnitude. It's an order of magnitude, but, you know, I got a fast Mac. And
so you're cross-compiling on the Mac?
No, I'm not. I'm on my Mac. I have a virtual machine, and I compile for that virtual machine, and I test, and everything works. And then I download the code onto my Raspberry Pi and compile there. And what took 3 minutes or 5 minutes to compile on my Mac takes an hour to compile on the Raspberry Pi. And it's compiled. And, you know, but it does compile, and then I run it there. And then, of course, if I change one file, it doesn't take an hour to recompile it. You know, it might take 5 minutes or so. And, you know, so that's how I develop. So would I use it as a development machine? Absolutely not. Would I use it, you know, to run my telescope? For sure. I have, and I'm happy with it.
Okay.
With a fan.
I don't have a fan. I just have that aluminum case. Now you and I were together one day in Pinnacles at 100 degrees, where I was trying to debug something in the daytime, and the internal temperature got to 85 C. So, you know.
Did it shut down automatically at that point? Or?
I just got slow. I mean, I don't remember. It was probably not a good idea to keep it on. I probably just turned it off.
I'm actually wondering about using it for solar imaging or.
Oh, I see.
You know,
so anyway, I don't know the answer for daytime, you know, hot stuff.
I think I added a fan to mine. I don't know. It's in a bag over here on the floor, but I'm pretty sure I added a fan.
For a warm summer night, you can image. No problem. You know, and you know, the temperature may get to 65, 70 centigrade, but 80 is where it starts throttling.
Okay.
So I found out even Arduinos get damn hot if you put them in a sealed box with the sun. The temperature of the air inside the box goes to like 130 degrees, no problem.
Well, no doubt you should shade it, right? I mean, but you know.
Are your images, I mean, the subs black and white or color?
Me?
Yeah.
I image with filters, black and, you know.
Black and white. Yeah, that actually helps because you have only 2 channels in the image, right? It's not completely color, and that actually makes Raspberry Pi to work. Otherwise, if you have 3 channels.
Well, Raspberry Pis can stream 4K video, though. So, I mean.
Yeah.
I mean, how many bits is a 4K? I mean, is a color image? I mean, there are a lot of people that shoot color. I think it does okay for that. You know, it could be that the download time, you know, the USB 3 time to get it from the camera to the Pi might be 10 seconds or something like that for the big image. But I don't think the processing, you know, just storing the image, you know, finding the stars, whatever, would be that bad.
Is that one of the things that is a thing that slows down autofocusing is download time, or you can do a region of interest in? Well,
I don't do a region of image. I do the whole image. Oh, by the way, getting back to that RGB question, you know, it's downloading the raw file, so it actually is the same number of bits as a monochrome, pixels as a monochrome, because it has a Bayer pattern. It really isn't 3 times. So now you're saying in the preview you could turn it into a color image, but and KStars does do that if you wanted to. But you also have the option of just not, seeing it as a monochrome if that caused problems. But I do know that a lot of people image with, color cameras, one-shot cameras. I'm sorry, what was the second question that I interrupted? I know I interrupted somebody. I know.
I was asking about the autofocusing possibly being slower because of slower download times with a Pi. But
yeah, I don't know. I mean, I think the download for my ASI 1600, it takes a ballpark a second to download over USB 3. From the camera to the Pi. It takes longer than that to move it from the Pi to your computer, but I don't do that. I just store the thing on a fast stick, and in the morning I carry my stick into my computer. Sneaker net.
Does the Indi driver have a USB throttling like the ASCOM driver does, or for the ASI 1600?
I'm not familiar. I don't know what you mean. No. Like I say, I know the practical answer is that it takes about a second.
He's talking about a setting for USB traffic, so that if you drop frames by allowing it to go too fast, you can slow it down.
I see. So Glenn is interplanetary now, so that's why I
No, that's not why, but it's one of the things that I think causes problems with ASI 1600, and I'm still not 100% sure which end of the graph which end of the knob is which, but I tend to run mine at 80 or 90, and they keep telling you, these Chinese translated instructions say, if no picture, decrease the throttling or something, which I'm not, sure which way they mean to go, but.
It's also got something to do with that setting has something to do with whether you're having fixed pattern noise,
right,
or walking noise even. They say that if you set it at around 70, that might resolve noise issues.
But the reason I brought it up now, Hy, is because that would affect how fast it downloads, where people have that set in the driver, if it's a driver setting in Indi.
don't know. I mean, I can show you the ASI 1600 driver. You want to see it? There it is. I mean, if people are, obviously.
Actually, and while you're bringing that up, you used to use EQ mod probably with your mount. How does the
who are you
driver,
talking?
I'm talking to you. Hi. How do you feel that the driver for the Atlas Pro in Indi compares to the driver you used to use?
I don't know. I don't know what you mean by used to use. Basically this is all I've ever used.
Oh, okay. You started using it when you first got your mount. I didn't know that.
Yeah, I haven't been. I've probably been doing this a year and a half or so.
Yeah, show us the camera tab.
All right, so here's the ASI. I mean, which tab should I be looking at? You can see.
Oh, well, the driver settings. Where do you put like gain and stuff?
Right here, control is gain. That's not here, right? Or high speed mode? I don't know. Is that it? I don't know what that is.
Yeah, hardware bin and high speed mode would be examples of driver stuff. Pattern
I don't
adjust.
know what that is, but I have them set to 0.
Pattern adjust.
How about
that's interesting.
bandwidth?
Oh, there you go. Good eye, Bruce. Yeah, bandwidth.
All right, 40.
So your homework is to futz with that and see what it does to your download speed and where it screws up your your images.
Thanks. Yeah. And look, just to show you, right? So this is the rest. There's plenty of other controls here, right? And so,
and it has an auto setting for the gain and bandwidth down there. Or what was it?
You want me to go back? Yeah, here.
Yeah, gain and bandwidth is set to auto. So, but you have gain up top. So I'm not sure how there's 2 separate gain settings.
I don't know. I mean, this is the way, all I've ever set on this page is the 16-bit and then the gain and offset.
Okay.
And the gain and offset, the offset is fixed, and then the gain is controlled actually by the capture tab. You know what I mean? Like this is the default gain.
Right.
But when you're taking a picture, you literally set, you know, over here, you know, you can set the gain, right? And
Per event.
yeah. So any event, there you go. But yes, Steve, you know, this is the way to control things, man. You know, you know, I have my pies outside, you know, God knows how many smoke particles are coming down on it. And I'm in here, you know. Poor Francesco. Oh no, Francesco's not breathing any smoke anymore.
You're muted.
Yeah.
Oh.
Yeah, I came back.
Well, very nice night of discussion, gentlemen. Thank you very much again, Hy. Thanks everybody for coming, and hope to see you all soon, at least online.
Thank you very much.
Same
Hy.
here.
Great
All right.
presentation.
Thank you.
Thank you very much. Hi.
Thank you.
Thank you, Hy.
Thank
Thank
you.
you, Bruce.
Yeah, right.
Bye-bye.